All right, we'll get started. It's time to, so you guys can have fun. Welcome back to the Lunch and Learn series. Just so you get an overview of what we're trying to do here, we're trying to put out feelers essentially to figure out what, how much interest we're going to have for in this topic area, and then we're going to decide in the future after we're done with all 5 series whether or not we're going to turn this into a class that we'll be offering. So your feedback and everything that you give us is going to be very beneficial. And so now we're going to talk about soldering and desoldering, and then we go on to the other 2. So, oh wait, do you have something to say? Oh, you? No, I was just making noises. Okay, so previously we were just looking at stuff. We weren't getting very intrusive with the printed circuit board, but now we're going to actually try to take stuff off or put stuff back on. So now we're going to desoldering, soldering. How do you solder? Have any of you soldered before? All of you? Pretty much?
How many people have soldered to the point where they were happy with it? All right, good.
Yeah, like happy, not happy.
Right.
Yeah, right? Right?
I find that's usually the
Did you get the nice pretty peaks? No? Yes? To someone? Like, I guess there's enough solder in there to provide a good contact. Well, anyway, you have your solder. Well, how do you solder? Essentially, the big thing that you want to take away is you want to be able to apply enough heat to both the pad and the component's lead point, and such that there's enough heat on there such that the solder will melt, and it'll melt and fill the hole and then come back up and provide a really nice contact. If you don't apply enough heat, you're going to start to see that the solder is not going to melt uniformly around the lead. But you'll see some pictures later on. So what do you need to solder? We need a soldering iron. We need some sort of soldering tip and some solder. And we'll go over each one of these different types of things. And tips from, yours truly, Craig and myself. So the first thing is a soldering gun. I don't know, if you've ever gone out there and said, I want a soldering iron, you're going to actually see this come up too. But you don't want this, you don't want this gun. Because
unless you're doing like piping.
Yeah, exactly. Unless you're going to be soldering some piping in your house or some sort of copper pipe or something, then you're going to want this, because this thing will get really, really hot. It will actually burn a hole through your printed circuit board, and that's not what you want. It's going to be applying too much heat at the tip. And the little metal piece there will actually get really red, and that's not what you want. So the next thing you'll probably find is something like called a soldering pencil. And this one, the heating element is actually inside the handle. And it's typically not temperature controlled. It's just going to vary. It's going to vary in what type of temperature you're going to get. You can't say I want 365 degrees on this, and you're not going to get 365 degrees. And it's very cheap. It's like $25, and it'll get the job done. But you're gonna I don't know. I don't suggest buying one. It's just not, and it's not nice. You're probably just going to end up with that tip too. You're not going to be able to change the tip or anything like that. So the next thing is, like, instead of having the heating element inside the the handle, the heating element is on the outside. And this is what you're most commonly going to find being used by us engineers and stuff like that. The heating element is inside this grain thing here, the weller. And the temperature for this one will range between 350 degrees to 850. And typically you want to set this temperature guy 100 degrees above the melting point of your solder. But is there anything else I want to say about this slide?
Well, the main thing is that you can control the temperature.
Yeah.
Right. So you can set it at 600 degrees Fahrenheit or whatever. And we'll talk about later, when you might want to set it at different temperatures. But that it just makes sure that you can apply the right amount of heat to what you're soldering. Right.
That's the huge takeaway about stuff that's temperature controlled.
So and these I think are only like $90 or $100.
Yeah.
They're not going to break the bank.
Yeah, this was like, depending on where you buy it from, it'll be like 100. And I mean 90 to about 125. I think I found the most expensive, this particular model. Weller also, oh, forgot. I'll just tell them really quick. So Weller also has, we can go back. There was a Weller model that I found that has the actual heating element inside the tips, or the controller inside the tip, which is you have to buy various tips, and it only regulated temperature at 600, and I think it was 800 degrees. So that was kind of neat, but it's not something you want to buy. It's too expensive because you have to buy all the different tips. And then we have so we fought over trying to determine how to say this word. And I think we decided it was called Hako? Hako.
The people from the company call it Hako.
The people from the company call it Hako. So we're going to say Hako is another one that you can vary the temperature yourself, figure out what temperature you want to set it at. And this is also about $90. So you can get this very cheaply.
So the one thing I will say about the Hakos, I have a Weller at home, and I like it a lot. The one thing I do like about the Hakos is the different tips you can get seem to be more accessible. Like I really had to hunt around for some different tip types for my Weller, but the Hakos seem to be a little easier to find various tips for. So
right.
That might be something you want to take into consideration. But they're both very good soldering tools.
Right. So here's our temperature. Where do you want to set it at? And this is what I was talking about. You want to set the temperature of your iron to about at least 100 degrees above the melting point of your solder, and you'll be able to see it on the spreadsheets of your solder what the melting point would be.
Pretty much any solder you'll be using for electronics work is going to be around the 360 to 370 degree Fahrenheit.
Right.
So usually you'll set your iron to like 600 to 650 degrees. For most electronics work, that's good.
Right. Now tip selection. There's various tips. There's all different types of tips they have now these days, but most commonly you're going to probably use this, like these four. But so the one on the right, your left, is the hoof tip. Usually they use that for like dragging soldering. You want to, on the, I think they're called surface mount packages, and they have the leads. You want to use it in ply solder in this dragging motion. So you want to use the hoof tip. This is a canonical tip. There's two varying widths. You're going to actually get more heat on the wider width versus the more thinner type thing. So, and you're going to get, I would say, oh no, I'm sorry, the canonical one. Not the canonical one, I'm sorry, the chisel. The chisel tip. The chisel tip is like the best for a beginner. These other ones are for more advanced people.
Well, I mean, the chisel is really, I think, the best all around.
No, right.
Drag soldering, you probably won't get into that if you're just starting soldering. But it's really not that hard once you do it a couple of times. The nice thing about those canonical ones is they can get very thin and very small. So if you're doing very small pitch work, and you need to do like individual pins, they're useful. But I mean, even for like small surface mount stuff, I usually just use the chisel tip.
Right.
And especially if you have some magnification, it's usually just fine.
Which is why we have a chisel tip. We recommend a chisel tip for most projects. You're able to, this is going to be able to apply heat evenly in most of these bigger projects where you're just trying to take a component and put it into the printed circuit board, and it's much better. It applies much more heat than the canonical tip.
Right. So the whole thing is heat transfer, right? So the more surface area of the tip you can put onto the metal, the better your heat transfer is going to be. And you'll notice with the chisel, they have like flat sides. So you can get it right flat on the pad on the board that you're trying to solder. So they usually work out very well.
Right. And it's also touching the lead on the other side. So it's got this like cone shape, like triangle shape. But it's not really triangle because I think it's a flat.
It's basically flat on
like flat on type. Yeah, flat on the top. It's very nice. So tip oxidation. If you leave your iron on for too long, it's definitely going to start to oxidize, and it's not good because then your solder won't actually flow off. It won't even stick to the tip. It's just going to slide down and
insulating the heat inside the tip.
It's not what you want. You want to be able to have as much heat onto the tip as you need. So how do you clean it? There's tip tinner. It'll clean the tip, and it's all it does.
I do. I've used this before a couple times. Do not breathe the fumes. I don't know what it's made out of, but they are noxious. You do not want to breathe them. I'm sure it's like would kill you or something like that.
I think some of the tip tinners come with lead-free and then leaded. Is that what they said?
For the tip
I've only
tinner,
seen lead-free.
But I don't think that's the fumes it's giving off.
It's from the
Yeah, it's from whatever else they have in there, but
it's this nasty stuff.
yeah, don't breathe.
Yeah, so you can use tip tinner to keep the. So the other thing you want to do is you don't want to let your iron get too oxidized, and you want to make sure you keep it clean so that there's enough heat going to the tip, and it also prolongs the life of the tip and your soldering iron, so that you're not like having to buy a new one right away. And a wire cleaner, this is probably, we think this is the better option than using the sponge. Because the sponge, what you do is when you touch the iron to the sponge, it like reduces the temperature inside the iron and it has to reheat again. So it's much better to just use the wire cleaner. Just wipe off the excess solder and some of the oxidation will come off of the tip using this wire cleaner.
So I think like most of the wellers come with the sponges, so you just wet the sponge before you use, which A is kind of a pain in the butt, because you got to get up and wet it every time you.
And then
also you'll end up burning holes in the sponge. You have to replace the sponges, and these actually will clean off any oxidation a little better as well.
Right.
So.
And it doesn't dry out.
Yeah. Yep. So I prefer this.
Yeah, most people do. And then we have FLUX. So FLUX is basically an organic acid that helps remove any oxidation, and it's better because it allows for better soldering between the joints on the on your board. And that's all I have to say about that. But you have anything else?
No, nope. I mean basically its whole purpose is to kind of clean the contacts on the board, because you know that even if the contacts look clean, there's probably some dirt or small amounts of oxidation on them, so this can be useful.
Yeah, and don't breathe it in.
Yeah, don't breathe.
Don't breathe. Yeah, don't. It's bad.
So I know a lot of people, especially if you're working with leaded solder, think that they're going to get lead poisoning from the smoke. Lead, in order to vaporize lead, you have to boil it, and lead boils at like 3,000 degrees Fahrenheit. Your soldering iron is not going to heat lead to the point where it vaporizes, but the fumes that are coming off are actually from the flux, and those actually are also bad. You can get asthma and other respiratory problems, so you still don't want to breathe it in.
So you can also buy a fume extractor, where it's just going to suck away the fumes from you, or you can just use a fan to blow it away as you're working.
As long as you're in a ventilated area, blowing it away.
Yeah, that's going to work for you. So I'm going to let Craig kind of like talk about some soldering here. But we're sort of tag teaming, so.
Yeah, I have to make it look like I do some work around here or something. All right. So the reason why I wanted to kind of talk about flux before we talk about solder is because it's important to note that most solder has flux in it. They'll have a rosin flux core basically in the solder. And this is kind of a very thick solder, so you can see the hole there where the flux is. So even if you don't put some external flux onto the board yourself, when you solder, you'll get kind of those fumes. And that's good because that flux is going to melt as you're soldering. It'll clean and deoxidize whatever you're trying to solder. So I mean, pretty much all solder has a rosin core. I think you can get non-rosin core solder, but pretty much all solder has a rosin core, so that's good. But there are different types of solder that you can buy. And basically they fall into two groups, which is leaded and unleaded. Right? So if you look at these are both made by the same company. The first thing I want to note is this solder is pretty thin. The diameter is less than 0.5 millimeter here. So I usually prefer that, especially for electronics work, because it's thinner, it's going to melt faster, which means you have to apply heat not as long to the things that you're soldering. Right? Just going to make your life easier. The other thing to note is, of course, one is leaded, the other isn't. I forget what the 97SC stands for, but that is unleaded.
That's actually 97SC. So that's a generic. I looked it up. It's a generic label that's made for multi-core code, but the composition of that particular alloy is 96.5% tin, and then 3% silver, and then 0.05% copper. So it tells you which, and all lead-free solder, you're going to get like tin, silver and copper, but it's going to be a variation. So depending on what type of work you're doing, the level of tin and the level of silver that's in the particular solder is going to vary.
Yep.
But this is the one that we use for electronic work.
Yep. So the leaded, you'll see it says 63/37. You might see 60/40. That's less common now. Pretty much all leaded solder is 63/37. And that just means it's 63% tin, 37% lead. So that's usually easy to pick out. Now, when would you want to pick lead over unleaded or vice versa? Well, generally, lead is technically better, right? Lead makes really good solder. It just even looks better, right? If you look at the lead solder versus lead-free, the lead-free looks pretty crusty. Another issue, kind of more concrete issue other than it looks crappy, is you get tin whiskers. There's a lot more tin in the unleaded solder. So you can see that kind of whisker thing there. They'll actually grow over time out of your solder joints, and they can cause shorts. So most of the industry has gone to unleaded, but for really important, like mission critical stuff like NASA, they usually get exemptions to use leaded solder so that they don't have problems with tin whiskers. In fact, I think that's actually a photo from NASA did a whole thing about it. So these can be important things. Leaded solder is typically easier to work with. Its melting point is typically better defined than lead-free, so you don't have as much issues, especially if you're just starting out with getting it to melt properly and things like that. So generally, lead solder works better. However, there's a big problem with using lead solder in electrical components and stuff, especially when you're mass manufacturing them, because a lot of the stuff ends up getting thrown out after a couple of years of use. And so you have all this stuff that contains lead now getting thrown into landfills and stuff. So this restriction of hazardous substances stuff came up out of the European Union, and most electronics manufacturers comply with it now. In fact, you usually have to get special exemptions to not comply with it. And basically, this means that you're not using components or anything that have like lead or mercury and stuff like that in them. Now, if you're just doing stuff at home, you probably don't care about this, right? And fair enough. So there are some concerns, even if you don't care about complying with this, with using leaded solder. Obviously, as I mentioned before, you're not going to be inhaling the lead unless you're like really boiling, like you really have to work hard to like inhale lead poisoning. But you are touching stuff with lead in it, right? So when you're soldering, don't hold the solder in your mouth, as like a third hand. Don't eat food while you're soldering. Make sure you wash your hands after use and things like that. Basic precautions. And stuff like lead is really bad because your body can't expel it. It's a cumulative thing over time. So, if you're soldering a lot, you don't want to be eating a lot. So, that's really the basics. If you select a good iron, a good tip, good solder, you're going to be in a good place to start soldering. As we mentioned before, you do want to kind of heat up whatever 2 pieces of metal or 3 or whatever you're soldering together. You want to heat up all those pieces of metal so that you can melt the solder onto the metal. What a lot of people do when they first start soldering is they will melt the solder onto the tip of the iron and then kind of like try to wipe it onto the metal, and that usually doesn't work very well. So what you want to do is heat up the metal that you want to solder, and then actually apply the solder to those metal pieces. And what you should end up with is a joint that looks kind of like a teepee, right? And you shouldn't be like a big ball of solder and things like that. It should look, this kind of looks like a Hershey kiss, It should look kind of like that. So you should have like these nice concave sides on each side of the lead if you're soldering like a through-hole component. Now, if you do something like trying to wipe the solder onto the components, or if you only heat up one part, like let's say you heat up the lead but not the pad, you'll end up with like this solder ball. And it's usually referred to as a cold joint because you didn't heat up the metal enough for the solder to really bond properly. So this is what it looks like here. These two on the left, you kind of have like these balled up balls of solder, and that's what you'll see typically with a cold joint. Now, these actually look very similar to these two over towards the right. And these are actually good solder joints. It's just that too much solder has been applied. So, I mean, really there's nothing inherently wrong with putting too much solder on there. You've got a good joint and a good connection. The problem is the more solder you put on, the more likely you're going to short it out with something next to it that you don't want to short out. And also it's difficult to distinguish between a cold solder joint where it just balled up and a good solder joint that has too much solder on it. Now in contrast, these two have not enough solder on them. You can see that it's gotten some on the pad here, but it hasn't gone all the way around. There is an electrical connection there, but you know, it's very likely to break off, especially if this thing's under any kind of stress. So what you want is something like these two, where you have, you know, everything kind of nicely filled in. You kind of have that nice concave fill. So that's kind of what you're shooting for. Now a couple of tips when you're actually doing through-hole stuff. Since you have to flip the board over and solder on the other side, do these short components first. So usually you do things like integrated circuits and stuff like that first, because you can flip it over and just rest it on those components. If you do tall components, like big electrolytics or something, and then you try and put those ICs on, you've got to kind of like hold it there with your finger and it can get to be messy. Now with things like resistors, capacitors, diodes, things like that, where they have these long leads, you can actually pull them through the holes and bend them so that when you flip it upside down, they stay in place. So that's usually how you keep them from falling out, although sometimes, you know, you may be working on a board where stuff's already soldered onto it, so you don't get to choose, and you just have to deal with what you have, so that can be a pain sometimes. When working with surface mount stuff, you usually want at least one pair of tweezers, because you're going to need to hold the component there as you solder. Now, usually what you do with these smaller components, like you see here, they're soldering a small resistor, is you'll take one of the pads and get that pad tinned, is what it's called. So you put a little solder on there. Then all you have to do is heat the solder up and push the component onto there. Now the downside to doing it that way is once you melt the solder, you've kind of burned off all the flux. So when you put that part on there, there's no flux to clean off the part. So you might get not as good of a connection. I mean, usually it's fine, but if you're doing production work, it's not good. So this is where you might apply some external flux, right? After you tin it, you apply some external flux and then put the component on there. And usually once you have one of the pads soldered on, the part will stay there pretty well and you can just go around and solder all the other pads. Especially with surface mount stuff, it's also useful to have some magnification. You can go fancy and get a nice, you know, binocular microscope, or it can be something as simple as a magnifying glass. The nice thing about, say, these microscopes is that you can actually use them to very easily look at the stuff that you're soldering. You can do the same thing with the magnifying glass if you have one of these big desk lamps too. But you at least want something to inspect the connection after you've soldered on there, especially for the surface mount stuff. It can sometimes be difficult to tell if you've got a good connection on there or not. So I also want to talk a little bit about desoldering. Usually if you're building a board, you need this in case you screw up. However, if you're kind of working on someone else's board, you may need to remove a component that's failed, or you might want to replace it with something else. So you need to actually take off what's already there and before you replace it. And really, desoldering is pretty straightforward. Usually you'll be doing something like this where you heat up the joint to melt the solder, and then you need something to remove the solder. So solder pumps are very useful. They're just little spring-loaded suckers. You push the button and it'll suck up the excess solder once it's melted. Desoldering braid is also very common. So it's basically just a copper braid. You heat up the copper braid on top of the solder joint and it'll wick it away. This isn't very useful for large amounts of solder. You usually want to use the solder sucker to get large amounts of solder, but then if there's any small parts left over, this will do the job really well. You can also get desoldering guns. Now these look very similar to the soldering guns that we told you not to use. In contrast, these look this way because they actually have a pump, an electrical pump in there that's sucking stuff away. The tip itself actually has a hole in the center where they're sucking the solder out. And so these are useful for electronic work, especially for through-hole components. They're particularly nice to have. For surface mount stuff, a hot air rework station is very nice to have. Basically, these are just, they shoot out hot air. Think of them like a hair dryer, basically, but they get a little hotter. And you can get these nice little different sized nozzles and things like that. The advantage here is because it's blowing out hot air, you can heat up multiple joints at once. Right? And this is especially nice for desoldering surface mount components where you have multiple leads. Now, I have one of these, and to be honest, I find this useful for a lot of stuff, including soldering. Right? If you are just soldering stuff, you tin two pads, heat it up with the hot air, and then stick the component on there, and both of them are soldered. So very useful to have in the lab. And they're not expensive. In fact, I think I saw one for like 30 or 40 bucks the other day. So they can get pretty cheap. I paid $100 for mine, so I feel like a sucker now, but you know. So really soldering is pretty easy, right? You heat up two pieces of metal, you melt solder onto them, you take the heat away, and the solder solidifies and has bonded those two pieces of metal together. We do have some soldering stuff set up in the back for anyone who wants to play around with it. We have a Weller station, and we also have a cheaper solder pencil, so you can play with one or the other or both and see how they differ. Couple of cautions: don't touch the iron. And you know, if I had a nickel for every time I burned myself, I'd be rich. You do it a lot, but just try not to. Again, don't breathe in the flux fumes. The solder we're using does have flux core, so you'll have some stuff blowing up in your face. I mean, you're not going to immediately, if you breathe some in accidentally, it'll be fine. But if you do it over and over again for long periods of time, you can have problems. And the solder is, actually we have some leaded and unleaded solder back there, so just make sure you wash your hands before you go eat anything. Don't want anyone getting lead poisoning and suing us. Anyone have any questions? Comments, concerns?
For desoldering, is it the same temperature or greater temperature?
That's actually a good question, and I meant to bring that up. So do you use different temperatures for different things? And the answer is yes. So, and for both soldering and desoldering. So if you're desoldering something small or you're soldering something small, lower temperatures typically, because you don't want to overheat the components. Most components are pretty resilient against heat, but you can damage things if you get them too hot. Especially with the hot air, because you're kind of like blowing it over the whole area, the chips and stuff will heat up quite a bit. Now, the one time where you will want to bump up the temperature is if you're working with stuff that's basically heat sinked. So if you look at a board, and I wonder if one of the pictures here has it. So you see this whole area where it's kind of lighter green, and then you have like kind of darker green around the traces here. This lighter green is there because there's a copper layer just underneath the silk screen of the board. And that's usually all ground. That's your ground plane. So anything connected to that is basically connected to a big copper heatsink. So anything that's grounded is going to take up more heat or a longer time to heat up. So if you're desoldering something connected directly to the ground, you might want to crank up the power a bit. And again, that's where being able to adjust the power on your soldering iron and things are nice.
The different solder, lead-free solder takes generally higher temperature.
Yeah, it
Yep.
looks like, I think it's like 5 to 10 degrees higher than lead. So, yeah. I mean, I've never really worked with lead-free. I've always used lead.
So I haven't had a whole lot of problems with lead-free. I've heard people have issues where there's like a Goldilocks zone where it melts really nicely, but if you go too high or too low, it doesn't like it. So again, pretty much most of the industry has gone to lead-free, so it works, right? But I mean, personally, I usually use leaded stuff just because.
Do most of the ones you buy, they come with some data sheet or something?
Yeah, you can usually get a data sheet for them, and pretty much all of the manufacturers will have like a hazardous materials sheet and stuff, so you can get all that information. Yep.
So I did some searching for solder on Amazon, and they also have they have this thing called Clean No Clean, and it's basically
For the flux?
Yeah, for the flux. It's basically just whether or not you have to clean up after, because there's a flux core inside. And usually, I think the picture he put up there had no clean on it.
Yeah, so
you don't really have to. Wait.
Right. Let me get back to the flux part here. It's way up here. So when you buy flux, it'll usually be labeled as clean or no clean. Usually the stuff in the solder is going to be no clean.
You'll see no clean.
And the difference is the stuff explicitly labeled no clean is non-corrosive. It will still leave a sticky residue, so you usually clean it up anyway. But the stuff that you have to clean is corrosive, so if you leave it on the board over time, it can eat away at your board. So that's another thing to note. But yeah, usually I've always used no clean flux and it works fine. But again, the board's all sticky after you use it, especially if it comes like you can get it as a paste or liquid, and if it's liquid, it kind of goes all over the board when you put it on there, so you end up cleaning it off anyway. And that's usually just a little isopropyl alcohol and a little rub it off.
Alcohol and a little bit of pad.
Yep.
And then wipe it off. And it just looks better.
Yeah.
And leave it on there.
Anything else?
Anything else?
No?
You guys want to try? Yeah?
Yeah. Well, go heat up the onions in the back.